Hello friends, welcome to Tutiostudy. Here's the next tutorial on statistics. Statistics is widely used today in many spheres of life. It is a science which deals with collection, presentation and drawing conclusions from numerical data. Statistics is used for presentation of data in a systematic manner. Data may be related to marks obtained by a student of class in certain examination, monthly wages earned by workers in a factory, profits of a company, or number of employed persons in different states, population of a country, per capita, national income, etc., etc. The numerical facts collected here is called data. To begin with, let's start with tally marks. To organize our data, we first arrange them into tally. The marking of strokes in tally are done like the first 4 tally marks are entered by vertical strokes. The 5th tally mark is entered by crossing diagonally the 4 tally marks already entered. This gives us a bundle of 5 strokes. The next stroke starts a new bundle. Like in our example, the families having one child are 3. So we put 3 strokes in front of it. Similarly, families having 2 children are 8. So we put a bundle of 5 stroke. Next, we move on to frequency distribution. Frequency distribution is a method to present raw data in an easily understandable form. Frequency distribution are of 2 types: discrete frequency distribution and continuous or group frequency distribution. Discrete frequency distribution is a very simple method. The construction of this distribution from the given raw data is done by the use of method of tally marks. In the first column of the frequency table, we write all the possible values of the variable from the lowest to the highest. In the second column, we put tally bars. Finally, we count the number of bars corresponding to each value of the variable and place it in the third column of frequency. Like in our example of discrete frequency distribution, the number of families having one child is 5, having 2 children is 6, and so on. This method is quite convenient only where the values in the raw data are largely repeating and the difference between the greatest and the smallest observation is not very large. Like in a case, the smallest value here is 1 and the largest value being 5. But if the number of observation in data is large and the difference between the greatest and the smallest observation is also large, then we condense the data into classes or groups. Such a distribution is called group frequency distribution. Here, we first put the class intervals in the first column. Secondly, in the second column, the tally bars are created. And finally, the value of the variable is calculated and placed in the third column, that is the frequency. Like in our example of marks obtained by 30 students in a class test, the marks are grouped in class intervals beginning as 1 to 10, 11 to 20, and so on. So the number of students who obtain marks between 1 to 10 are 2. Those who obtain marks between 11 to 20 are 6, and so on. Now, Let's talk about class intervals and class limits. Each group of class into which the raw data is condensed is called a class interval. Like in our above example, 1 to 11, 11 to 21 are all class intervals. Each class is bound by two numbers which are called class limits. The number on the left side of the class interval is called its lower limit, and that on the right side is called its upper limit. Thus, in the class interval 11 to 20, 11 is the lower limit. Next, we talk about the size of the class interval. The class size is the difference between the upper limit and the lower limit of a class. Like in the class interval 1 to 11, the class size is 11 minus 1, that is 10. The class marks of a class interval is the mid value between its upper limit and its lower limit. The formula to calculate class marks is upper limit plus lower limit divided by 2. Our next topic is range. Range is the difference between the maximum and the minimum value of the variate. For example, in a raw data, if the maximum value is 58 and the minimum value is 8, then our range is 58 minus 8, that is 50. Our next topic is cumulative frequency. The cumulative frequency of a class interval is the sum of frequencies of all classes up to that class, which includes the frequency of that particular class. Cumulative frequency distributions are of two types, that is, less than and greater than or more than frequencies. For less than cumulative frequency distributions, we add up the frequencies from the above. Like in our example, we first convert the class interval into less than types using the upper limits. Instead of 0 to 10, we write less than 10. The frequency for the first class interval remains the same, that is 3. Then we add the frequencies. The second frequency of less than 20 becomes 3 plus 12 is equals to 15. For less than 30, it becomes 15 plus 36, that is 51, and so on. For greater than cumulative frequencies, we add up the frequencies from below. For example, in our case, the class intervals are changed in more than type using the lower limits. Like for more than 0, in place of 0 to 10, the first frequency we add up all the frequencies, that is, it becomes 378. For second frequency, that is more than 9, we subtract 3 from total. 378 minus 3 will give us 375. For the third frequency, it becomes 375 minus 12, that is 363, and so on. Thank you friends for watching our video. Do subscribe our channel on YouTube, like us on Facebook, and follow us on Instagram. Thank you.